But nonetheless, we're about to go ahead and get started with this stream. All right, so I don't remember if this one was Copilot or chat, but I was like, for the average high school student, give me some problems that like I might have forgot how to do some stuff over the summer. So they gave me these, and I'm gonna just go like not in order, but I'm gonna kind of skip around a little bit. Some solving, some factoring, graphing, systems, polynomial. There's a whole bunch of stuff. Word problems, a little bit of probability. So I'm gonna try all of those. But all right. Let's see how this goes. All right, so I guess I'll start with number one. Basic algebra. We're not even solving yet. We're simplifying. Okay, this should be easy. Um so we're gonna go, yeah, they start out super duper easy. But I will say, I have dealt with people who I still see some people getting these wrong. Combining like terms, notice how both of these have an X on them and this one does not. So you can't combine it with the rest. So this is all I'm going to put. 3x plus 5x is 8x, and then just keep that minus 2. So, all right, well, I'm going to see which ones I want to skip. Low key, number 2, I don't want to skip. I'm going to skip all the ones that I think a lot of people would get. But if I see ones that I can see people messing up on, I'm going to do those. Like this one right here. I can see some people being kind of iffy on simplifying that. Distribution. Whenever I see something, I'm not going to say something. Whenever I see a coefficient right on the outside of parentheses like that, that's how I know I'm going to distribute. I always tell people, if you're like a starter, draw your arrows just to, be safe. And then one mistake that I see a lot is when people distribute, I know they don't mean to, but they add instead of multiply. So I'm going to make sure to multiply instead of add the 4 and the 2. And then another mistake that I see is people they just neglect the negative sign. So I got to make sure I carry that over. And then 4 times 3. And then keep on my plus 7. So I'm going to go 8x negative 12 plus 7. I'm going to go like that. So I guess I should also highlight or box my final answer too. All right, so that's simplifying, distributing. Also, while highlighting a couple common mistakes, let's do. I guess we'll do number 4 too. These are all kind of different. Actually, no. I'm doing number 3. I've seen people mess up on number 3 too many times. And I get it. It's like, I get why, because you see a number right on the outside of parentheses, so you want to think distribute. But you got to remember, never have we ever distributed exponents. So you don't distribute the exponent of 2. You just have to think about, what does it mean to square something? And that is to take whatever's in parentheses and just multiply it by itself. That gets probably 87% of people. Bober, what's good, bro? I asked Copilot to come up with some problems for me to do for the students who might have like forgot stuff over the summer. So this is all I'm doing right here. All right, but yes, exponents we don't distribute. We just think about what exponents mean. They mean to multiply whatever's in parentheses by itself. That does mean I'm gonna have to FOIL. If you're first starting out or like need a refresher, I would say go one letter at a time. And what I mean by that is like my 2 X's make my first. This arrow right here would be my outer. This arrow here would be my inner. But if you've done this enough times, then you probably do your outer and your inner, like combine them in your head. So I can just look at it and tell that my outer is going to be 2x and my inner is going to be 2x. So I can just combine those to get a 4x. And then my last is just going to be 2 times 2, which is 4. But in case anybody is wondering, the arrows that I'm talking about look like this. That's my first. This right here is my outer. This right here is my inner. And then this right here is my last. If you did it right, shout out to Anthony. This should look like a crescent moon if you drew your arrows correctly. But then after that, you just got to make sure you multiply and not add. And then that's it for that. Yes. A lot of people forget stuff. If you don't have like a specific set of problems, just ask GPT. But yeah, man, if you do, let me know. Calculus students are fun to tutor, man. I'm excited for you. But all right, I'll go ahead and do number 4 as well, just because, again, I can see the mistakes. 6x squared minus 3x. That whole thing over 3x. Now, you got options. I can see different people doing different things from here, because part of me wants to factor the numerator first, but you can also split this up into 2 separate fractions and just simplify each fraction. So I'm going to do both ways, though, just to see like what happens. So first, I'm going to factor out the numerator. I'm noticing that they both have a 3 and they both have at least one x. So I'm going to factor out a 3x. And remember, when I factor something out, I'm just trying to like distribute backwards. So I'm asking myself, like, what do I need to multiply my 3x by to get a 6x squared? And so if you're new at this, I always recommend doing like numbers first and then do the x's. And what I mean by that is like 3 times what gives me 6, and then x times what gives me x squared. So just like that. And then if you want, you can check as you go. 3 times 2 is 6. X times x is x squared. Multiply them together. You do get 6x squared. And then I'm going to go minus 3x times what will give me 3x. Well, 3x times 1 will give me 3x. And then I still got my 3x on bottom. And then you should notice that these 3x's cancel. And so once they do, I think I'm left with a 2x minus 1. Like so. But the other way I was doing or thinking about it was like this. I noticed that I got like 2 different terms up top over one singular 3x. I'm going to split it up like this. Watch. Boom. Put that over 3x. And then I'm treating it like as if they had common denominators, which they do. Like this. So think about it like if you were condensing this, they have common denominators, so you can turn it into one fraction. I just did the opposite. Milan, what's good? So I'm going to simplify each fraction individually. The first fraction, I got a 6 over 3. That's 2. And then I got 2 x's up top and 1 x on bottom. I'll write it like this so y'all can see what I'm talking about. Instead of x squared, I can put an x times x. And then you can see that one pair of x's cancels out. Remember, things can only cancel out in pairs. So the 6 over 3 makes a 2. I'm left over with 1x minus anything divided by itself is just 1. And as you can see, I get the same answer. Let's go. All right. I'm about to take another bite. This is good. Yeah, this is like becoming my favorite bowl already. Okay, next. Definitely got to do a solving one. Let's see. In the interest, like, so I can do every type of problem. I'm not going to solve every one. I'll do 8. I'll do 8. And it looks like this right here. So we're just solving for x. There is an x on both sides. Okay, so that's the equation. I'm going to obviously first notice that there's an x on both sides. So when there's an x on both sides, you can't get x by itself unless x is only on one side. So at some point in the process, I'm going to have to like make one side of x's cancel out somehow, just so you know. But okay. Again, I noticed that there's a coefficient and a coefficient, the 5 and the 3. I'm going to distribute both of those like so. I always recommend people draw their arrows. So my first arrow would be 5x plus, not 6, but 5 times 1, which is 5. And then that's going to equal 3x. Bring over my minus, and then I'm looking here. 3 times, really, I think of it as a 3 times a negative 2. So it's going to be a minus 6 or negative 6. Okay. Here's what I was talking about when I was saying that you notice that there's an x on both sides. Actually, you know what? I'm gonna bring this. I'm gonna go like this so it doesn't confuse people. That did not look good. All right, I'm gonna go like this. All right, so I got a 5x on the left and a 3x on the right. One of those is gonna have to cancel out. I'm just gonna subtract 3x from both sides just to make sure when I combine like terms, I don't have any negatives. That's just going to make my problem even harder to work with. But okay, so my 3x's on the right cancel out. Those are gone. On the left, combine like terms. I see people mess up here too. You just got to pay attention, bro. It's an x right here and an x right here. These are the two terms that you're going to combine. And if you just look, you see it's 5x minus 3x. That's 2x. And then my plus 5, I just bring it down like that. And then equals, and then I just write whatever is left over on my right side, which is a negative 6. One mistake that I see a lot, people just don't pay attention. And they see the number and they forget that the sign is attached to the number. So I'm not bringing down a 6, I'm bringing down a negative 6. All right, so now if you notice right here, I don't have an x on both sides anymore, so I can just get x by itself. So I'm gonna subtract 5, and then that'll be what, 2x. My 5's cancel. Negative 6 minus 5, negative 11. I see a lot of people get tripped up on that too. And I also say to get rid of that 2, I've seen probably like 70% of people try and subtract 2 from both sides. And again, I get it, but you just got to pay attention. That 2 and that x are being multiplied. So I'm dividing by 2 on both sides. I'm doing number 8 right now, but my full like work and stuff is on Twitch. So here's what I'm putting as my final answer for number 8. All right, so that's solving equations. I would do an inequality as well, but it's pretty much the same process. You just got to make sure, remember, when you're multiplying or dividing by a negative sign, make sure you flip the inequality sign. Really easy to forget how to do it or forget to do it as long as you do it. But let's move on to factoring. This is where it gets fun. I'm going to do 1, 2, 4, and 6. 1, 2, 4, and 6. Let me make a new section right here. These aren't even super duper bad either. All right, so factoring number 1, here it is. Arguably the most basic type of factoring. All right, what I notice is a trinomial. Nothing's in common. That's really all I need to know that this is, I know some people call it different things. I call it double parentheses x and x because that's how you want to start it off. 2 parentheses next to each other, they are about to get multiplied. And then if you just think about like what 2 things can multiply to get x squared, that's really only possible if you do x times x. So you can already see, like, if I started to check my answer, my f of FOIL will be x times x, which is x squared, which is why I call it double parentheses x and x. I know it's kind of long-winded, but it tells you how to do it. Double parentheses x and x. The rest of this, you're just knowing your times tables. You're thinking of two numbers that multiply to get this, but those same two numbers have to add to get this. That's literally it. So if you know your times tables, then you're good. And I know that 5 times 2 is 10. I know that 5 plus 2 is 7. So I'm going to go like this right here. And that's it. That's literally it. If you really want to, which I suggest, unless you're like an experienced factorer, FOIL your answer or like multiply your two factors together and make sure they come out to the same as like the original problem. If you look, try and FOIL it in your head, you can see that you'll get an x squared and then it'll combine to get a 7x and then you get a 10. But that process is only when it's like a trinomial with nothing in common. Next one like this. The easiest method to factor, but the hardest one to recognize. If you have the ability, this is x times x, and then 16 is just 4 times 4, then you're good. Once you recognize that, it's so easy. It's two parentheses. One of them has a plus sign and one of them has a minus sign. And then it's called difference of squares because they're both perfect squares. What times itself will give you x squared? X times itself will give you x squared. And then what times itself will give you 16? You just have to know that 4 times itself is 16. So it's really easy to do, but the hard part is recognizing it. So that's that. All right, let's do another. Oh, let's do a solving one. This one is not any worse. It's just one extra step. Okay. Oh, my fault. I didn't see the chat. It is algebra fun. Do I use box? I never, for every year, I've never taught box method. I just don't. It's just a waste of time for me, honestly. But okay, so for this one, I'm noticing that it's a trinomial. 1, 2, 3 terms. Nothing's in common, so I'm gonna do my double parentheses x and x. I do know some people like the box method. If you like it, then by all means use it, but I just don't prefer it. Okay. Thinking of two numbers. Those two numbers have to multiply to get this, to get a 3. But at the same time, they gotta add up, to get -4. So people do get tripped up right here just because like thinking of two numbers is not always the easiest thing to do. But it just comes with like experience, I guess. Once you do it enough times, it gets easy. And I will say paying attention to the signs helps too. Like if you think about it, two numbers got to multiply to get a positive number, but they also got to add up to get a negative number. If you know, that's only possible with two negative numbers. Negative times a negative is going to give me a positive. Negative plus a negative is getting more negative. So this is my factorization. And then notice the equal 0 means I'm trying to solve. So I'm really just trying to think of what x number. Let me highlight it. What number for x can I sub in to where it's, well, I'll say this. These two things are multiplying together to equal 0. And you remember from a little kid, or from being a little kid, that 0 times any number, I'll just say 4 randomly. 0 times any number is 0. So if I want this thing to equal 0, I want my entire first parentheses to come out to be 0. Because then it would be 0 times some other number equals 0. So you really just got to think, what number minus 3 gives you 0? 3 minus 3 gives you 0. And then using the same logic, this first factor can be any number, and then this second factor could be 0. So you got to think, what does this x have to be to make your parentheses turn into a 0? X will have to be 1. 1 minus 1 is 0. 3 minus 3 is 0. Those are my two x values right there. So really easy, provided you know your times tables. Really, that's all it comes down to. All right. Quadratic formula. I'll do this because I want to hit like more problems. So I'm gonna do this for quadratic formula. I'm just gonna write it and then like talk about how to do it. No, this is number 6. So the equation is this right here. Plus x minus 2 equals 0. And then what you want to line it up with is the whole format for a quadratic, which is this right here. If something is formatted like that, then it is a quadratic. And then to solve it, you would first try to factor it. And then sometimes you will, sometimes you won't be able to. If you can't, then this right here is an equation or a formula that you can use, to solve any quadratic. Talking and writing at the same time is not easy. Some people memorize it, some people don't. Again, once you do it enough times, you just kind of forced to memorize it. But line all your coefficients up, and then after that, it's literally just replacing letters with numbers. You're not doing anything more. So like what I mean is, if you look ax squared, a is just the coefficient of x squared, which is a 3. B, this one I guess is a little tricky. It's the coefficient of x, which when you look at x, there is no like nothing right there. You have to know that there's a 1. There's a 1 if there's no coefficient there. So B is 1. Signs matter. I know it says plus C, but if you look, that C term is negative. So C is going to be -2. Okay, so I'm not going to do this one in its entirety just because I want to do like more problems. But I'm telling you, take the formula, replace all these letters with their respective numbers, and that's it. And then simplify, of course. But if this could have been one where we got like complex solutions, then maybe I would have did it. But that's how you do it. Okay, domain and range. I feel like those two words give some people a headache. All right, so this next functions and graphing is what they're calling this. All right, so their first question says, it's asking what's the domain of this function. Look. And you do have to be able to notice what type of function this is. The fraction bar lets me know that it is a rational. So you got to recognize that. And then you also have to just not even know, just remember that you can't divide by 0. So when I'm asking about like domain, the best way to answer that question of what is a domain is to think about what type of function it is and what is impossible in regards to that type of function. And when I say impossible, like I'm dealing with a fraction. What can I not do? I can't divide by 0. So any x value that's going to make me divide by 0, that x value cannot be in my domain. Any other x value can be in my domain. But if it's going to cause there to be like a break or just like a point of non-existence, then that x value is excluded from my domain. So here's what I'm going to put. If you look at the denominator, the only time it can be 0 is when x is 2. Because 2 minus 2 is the only thing that's going to get you 0. Any other number that I plug in for x will give me a non-zero number on bottom. So that's fine. You're allowed to divide by any number so long as it's not 0. So I'm going to do this. Actually, no, I'm gonna do it like this. I'll do the braces. All right, so that's one way to write it. Basically, it's just a whole bunch of fancy symbols that say x can be any number except for 2. That's all it is. But all right. Okay, so I can do a function evaluation one. Low key, I want to do a lot of these ones from functions and graphing. All right, yeah, let's do it. So I want to do 2 is not that bad. I'm gonna try that one. It says evaluate. Function evaluation, that's another thing that I feel like confuses a lot of people. All right, so they give us some function f of x. It is 2x squared minus 3x plus 1. And then what they want us to do is evaluate this function whenever whenever x is -1. F of -1, that's what they want to do. Or that's what they want us to find. Literally all you do whenever you see an x, just replace it with -1. Reggie, I asked ChatGPT to come up with some problems to do to like remind kids how to do math, basically, because I know a lot of people forgot over the summer. So Chat just gave me like a whole list of problems, and I'm just doing them. Full stream on Twitch, by the way. But all right, I'm gonna rewrite my function, but instead of putting an x, I'm gonna put a -1. That's all I'm about to do. This right here should be mindless. Making sure I'm using parentheses, but I'm literally replacing x with -1. And then I'm just going to evaluate. Order of operations tell me parentheses come first. There is no parentheses like that has stuff in it. So I'm going to skip the p. Exponents come next. I see -1 squared. -1 times -1. That's negative times a negative. That's a positive 1. Times 2 is 2. Minus 3 times -1. So that's really minus -3. Once you do it enough times, you'll hear the phrase minus negative and you'll associate that with plus. So minus -3 is the same thing as plus 3. And then plus 1. And then we just add them up. 2 plus 3 is 5. 5 plus 1 is 6. Okay. For the Twitch stream and the playback, just so you know, an example of checking your work, I can use Desmos or like any graphing calculator for that matter to graph f of x, and then I can either confirm graphically or I can use Desmos to like tell me what f of -1 is. So I can go f of x equals, what was it, 2x squared plus 3x minus 1. No. Minus 3x plus 1. So there's a graph, and then if I look, whenever x equals -1, you can see that the y value is at 6. You can see it right there. Let me scroll. You can literally see it right there. -1, 6. And then on Desmos, if you want, you can also just type in f of -1, and it'll tell you what that is right there. So that is kind of helpful. But all right. Let's see. Graphing a linear, that's not too bad. I can do that one. Slope intercept form, you just got to know what the m and the b are. That's pretty much it. So if my equation function looks like this, I'm going to identify my y-intercepts. That's the +1. I don't like that color on that ink. Let me try this. I think that's a little better. So that green, that's going to be my y-intercept. And then the blue is going to be my slope. What I prefer people do is whenever they're looking at their slope, turn it into a fraction. That way it's just rise over run. Easy. So I'm going to just sketch out a quick little graph. It's not going to look pretty. but you'll get the point. So boom. All right, so y-intercept is +1. Let me make some tick marks real quick. Hold up. I shouldn't need too many. All right, so y-intercept is 1. That is the point where my line is going to touch the y-axis. And then my slope is 2/1, rise over run. The 2 is how many I go up, and then the 1 is how many I go to the right. The most common mistake I think I've seen is people wanting to rise and run from the origin. But remember, it has to go through that y-intercept. So I'm going to start from the y-intercept. I'm going to rise up 2, and then I'm going to go to the right 1. And then I'm going to put my next point. So it's going to be like right there. I'm just going up 2 and over 1. And then you really, technically, to make a line, you don't need a whole bunch of points. All you need is 1 point. So that's all I'm going to use. Let's do this color. So this is going to look bad. All right, there we go. That's not that bad. But yeah, that's how you graph the line. All you need is 2 points, and that's it. Okay. This is a lot of problems, bro. I'm trying to think what are the good ones. I'm gonna try to do the ones that I feel like people would either mess up the most or just forgot how to do. And system of equations, I've had too many people ask me stuff about that. So let's just do systems of equations number 2. I feel like I'm playing Jeopardy. All right, 3x plus 2y equals 12. Metro, you need to stay in the stream, my boy. Talking about some 2 plus 2 is 3 is crazy. Okay, 3x plus 2y equals 12, and then I got x minus y equals 2. That's my system. I'm going to try to, well, first of all, it's a system of equations. I got to solve for both x and y. You have, I don't know if you call them strategies. I call them methods. You got really 3 different methods to try to figure out what is x and what is y. A lot of times you have options. You have choice. And to be completely honest, that right there is what confuses a lot of students. Because I'll be like, if your problems looks like this, use this method. If it looks like this, use this method. And then we'll do some where it looks like you do one method, but you can really do the other method, or vice versa. So I understand the confusion, but just know that there's never just like one and only way to do a system of equations problem. On any given problem, I can use any method. It's just that some problems are like better catered for other methods, if that makes sense. Metro, appreciate you, bro. Yes, sir. I can't wait to do some harder problems, so I'm not gonna lie. But anyway, I say all that to say, before you like start writing stuff on a system of equations problem, just pick a method first of all. And like I said, you can go substitution, you can go elimination. You just gotta pick one at the end of the day. Low key, I kind of want to do both. I might do both. Same old Matt. Appreciate the share. I'm gonna do elimination first. I'm not gonna lie. If I'm doing this problem, I first see elimination, so that's what I'm gonna do first. And the thing about elimination is, I got an x term in both equations. I got a y term in both equations, and then I got a constant by itself in both equations. Once I see that, I'm like, all right, I can go elimination. Metro going crazy. Appreciate you, bro. All right, so in order to do elimination, as the name of the method suggests, you want to pick a variable and eliminate it. That also leads to confusion, because remember how you have choice in how you can pick like which method to do? You can also have choice in terms of what variable to eliminate. So it gets dicey. So I'm gonna just pick to eliminate the y's. Why? Because they already have opposite signs, so they're like close to canceling out. But what I want is this bottom negative y. I want that to be a +2. Or I want that to be a -2y instead of a -y. So what I'm gonna do, I'm gonna multiply that by 2, but I also got to multiply the right side by 2. So watch what happens when I simplify this. I'm gonna distribute my green 2. Watch what that becomes. That's gonna give me a 2x minus 2y, like what I wanted, equals 4. And then the top equation, I'm gonna just leave that how it is. I'm just gonna copy that over. So that's a 3x plus 2y equals 12. All right, so if you notice, the plus 2y on top and the minus 2y on bottom, those are gonna cancel out when I add my two equations up. And I'm not gonna lie, that still feels kind of weird to me that you can do that. You can just add equations. But that's what I'm gonna do. 3x plus 2x, that's gonna be 5x. 2y minus 2y is 0. That's the elimination right there. That's why they call it that. Equals 12 plus 4 is what? 16? Why would they give us numbers that come out like this? But anyway, to get x by itself, I'm gonna go boom. I'm gonna just leave my answer as a fraction. One thing I will say is I see a lot of students try to go for their calculator right here. And I mean, it's not wrong, but there's just no need to take an extra step to put this as a decimal. You're just wasting time. Just keep it as a fraction. Okay. I'm just double checking to make sure everything looks good. 3x plus 2y equals 12. 2x minus 2y equals 4. Add them up. Okay. And then, so I have x. All I got to do now is get y. And again, you have choice. You can pick the top equation or the bottom equation. You can pick the distributed version of an equation. You just pick an equation and get y by itself. Now that you know what x is. So I'll do, let's go purple. All right, so I'm just going to choose the bottom equation, the original bottom equation, x minus y equals 2. I'm going to use that to solve for y. And I'm not going to lie, here's what I'm going to do. Instead of writing the number 2, I'm going to still write the number 2. But see if you can figure out why I wrote it like that. But all right, so in getting y by itself, I'm going to choose to add y on both sides. First, I'll go one step at a time. So then I'll be left with 16 over 5 equals 10 over 5 plus y. I'm one step away. I got to get rid of the 2 or the 10 over 5. So I'm going to go like this. I'm going to go like this. And then hopefully you notice that I did it like this so that I got common denominators. 16 over 5 minus 10 over 5. That is going to give me a grand total of, what's that? 6 over 5. And that's my y. What's your y? That's my y. All right, bet. That's how you do it. That is elimination. I guess I'll like run through substitution real quick. So real quick, I'm not even going to do the whole thing, but look. You remember how this was my bottom equation right here, x minus y equals 2? If I choose to, I can get one of these variables by itself and just use that in my other equation. I'm definitely going to write that out because I know that probably sounded confusing. So look, if it's x minus y equals 2, you should agree that the easiest variable to isolate is x. So I'm going to go boom. And then my equation will be x equals 2 plus y. So that's my x. In my other equation, wherever I see an x, I'm not going to put x, but I'm going to put its equivalent, which is a 2 plus y, because those things are equal to each other. so I can like interchange them. So what that would look like, this would be my second equation. I probably should have set this up a little bit neater. That 2 is just telling me that that's my second equation. This 1 is telling me that that's my first equation, which was 3x plus 2y equals 12. And notice I said x, but I didn't put x. I'm going to put, well, I am putting x, but I'm putting another name for x, if you can think about it that way. So from here, you have one equation and your only variable is y, so I can just solve for y. So let's just do it real quick just to check to make sure I did it right. So if I distribute that 3, that'll be 6 plus 3y plus 2y equals 12. And then I will subtract 6 from both sides, and then I'm going to combine the like terms. I'm going to get this right here. And I guess I should probably show my work. I'm subtracting 6 from both sides. 12 minus 6 is where I get this 6 from. 3y plus 2y is where I get the 5y from. And then if I'm trying to get y by itself, I'm dividing by 5. So I will get y equals 6 over 5. And if you notice, same thing. Bit. Yeah, I know my TikTok crashed. I seen that, Metro. Let me see if I can just close it real quick. Hold up. That's the first time that's happened in a while, honestly. So I'm kind of surprised it happened. I don't know how it happened either. But I'm going to start that up in a second, and then let's do some more. I'm trying to move on to a different topic for real. Let's see. I feel like polynomials, that's pretty easy. Ooh, I'm going to do solving rationals number 3. I'm going to start my TikTok back up, and then I'm going to do solving number 3. Here's what I'll do. I guess because I was not showing my work on TikTok's stream, I guess I'll show it. I guess. All right, we'll get rid of this. We'll get rid of this too. Actually, no, we'll just hide that. All right, hold up, y'all. I'm fixing my TikTok stream. This is not the best looking stream, but it'll work. If they want the real thing, they can come to Twitch. Pause if necessary. All right, so I'm going to go boom. And then boom. All right, we're going to roll with that. So we said next we're going to do, let me actually hit go live. We're going to go rationals. All right, we're back live on TikTok. W ad. Wait, what you talking about? All right, so boom, we're back. I'm gonna do. All right, I'm gonna go rational expressions. Oh, I'm doing the solving one. Let me make like another little divider. All right, so this one does give a lot of people some trouble. Let's see. The only thing, I don't like how this thing is formatted, but I think I know what they're trying to say. They're trying to go 1 over x plus 1 over x plus 2 equals 3 over 4. All right. Bet, Metro, we're back. I got to remember that I can hit people with ads, bro. I got to learn how to do that. Metro, you got to teach me how to hit them with an ad. I'll figure it out later, though. But all right, so I'm solving for x. Thing about this one is two fractions being added. And you literally just got to start by remembering, like, what do you know about adding fractions? Or, like, what do you have to have? You have to have common denominators. So, here's what I'm going to do. That first fraction, I'm going to multiply it by something. That second fraction, I'm going to multiply it by something else with the goal of making both denominators the same. I'm going to just show you how to do it. You multiply one denominator by the other. And you want to multiply by 1 because that multiplying by 1 doesn't change anything. Kellen, what's good? So what I'm doing in purple is I'm just multiplying by 1. I'm going to do the same thing on the other fraction, but I'm going to make it to where there will be common denominators. So look, I got an x over x. That's just 1. Both of those fractions, I'm just times them by 1. But if you notice, both denominators are the exact same. Even though the order switched with multiplication, that doesn't matter. So this is equivalent to this. Watch. In the numerator, I got a 1 times x plus 2. That's just x plus 2. On bottom, actually, you know what? I'm going to do this. Since you can already tell that both bottoms are the same, I'm just going to smush them into one big fraction. And the denominator will be this. That is my common denominator. My first numerator was x plus 2. And then I know you can't really see it, but there's a plus in between there. My other numerator is just an x. And that equals 3 over 4. So it still looks kind of complicated a little bit, but at the very least, we have fraction equals fraction. Literally, once you have fraction equals fraction, you can simplify it like what I'm about to do, but from there, all you got to do is cross multiply. Well, not all you got to do, but that's the next step, I guess I could say. And then you will have no fractions on the left nor the right. So what I'm going to do, the numerator simplifies to a 2x plus 2 because the two x's combine. And then let's see. Yeah. I'm gonna just keep it like this for now. Cause I still gotta cross multiply. And that's what this is what that looks like. Metro, appreciate you. Good looking out, cuz. Alright, so when I cross multiply, it doesn't matter which one you do first. I always just do top left times bottom right. Spam it, shoot. That's gonna look like this. What I just wrote is the top left times the bottom right. That's what that is. And then I'm going to go equal. And I'm going to do the exact opposite. I'll even highlight so y'all can see the two things I'm multiplying. For anybody in there who forgot how to cross multiply. I'm going to go green times green equals blue times blue. That's what I'm doing right now. Cross multiply, butterfly method if you want to call it that. So blue times blue would be this right here. Look, I'm gonna write it like this: 3 times x plus 2. That is literally just a 3x times x plus 2. That's what I'm gonna do. What grade do I teach? A guy mathematician. Is there not a lot of them on here? I don't even know. But this year, geometry, calculus. That's it. Last year, and like the 3 years before that, Algebra 2, calculus. So to answer your question, basically everybody except freshmen, thank goodness. But all right, anyway, I got an x on both sides. I can't just start canceling stuff out yet. I got to distribute my 4, and I got to distribute my 3x. So we're going to practice good habits and draw our arrows. Unless you've been distributing for years. I say draw your arrows. Mostly women. That's what's up. How much do you need to review before you teach to be ready? It depends. If I'm doing something like this, I'm not gonna lie. I'm gonna just wake up and go to work. But if it's like some calc topics, I'll have to like watch some videos or like go over some notes like the night before. But the thing is, I've been teaching it for long enough now to where it's like, I'm not gonna say it's second nature, but like I can figure it out, you know. But all right, if I'm distributing my 4, that'll be an 8x plus 8. And then this will be a 3x squared plus 6x. That's my next step. And it does look like we're not really getting anywhere. But I think like part of math is just paying attention, bro. You have to be able to notice this term right here. If you notice that term has an x squared, that makes this equation considered a quadratic equation. And there's like a certain way to go about solving quadratics. Likely, you're going to have to factor when you're solving quadratics. And before you even do that, what you want to do to set yourself up to factor is make it to where everything in the equation is on one side and then 0 is on the other side. That's ideal. So what I'm going to do, and I prefer my x squared term to be positive. So what I'm going to do is I'm going to move everything from the left side to the right side. So that 8x is positive, so I'm going to subtract it. And then I got to do better with my colors, bro. I'm just kind of all over the place. And then I'm going to subtract 8 from both sides like so. Boom. All right, so 0. Hopefully you can see the 8x's cancel and the 8's cancel, so I get 0. And then on the right side, nothing combines with the x squared. So I'm just going to keep it. And then if you notice, both of these other two terms both have x's, so I can combine those. Differential equations, I'm down. Oh, yeah. Some of these, like, it's possible to do it in your head, but if you know me, I never advise it. But all right, I'm just combining like terms. And then bring down my -8. I was doing some sequences and series earlier this week. I haven't touched differential equations in quite a while, but I am definitely down to do some. For sure. All right. Me personally, when factoring this, it is a trinomial. There is nothing in common. Some people like the box method. Some people like the big X method. I don't do none of that. Slide and divide. Shout out my man, Mr. Benson. Mr. Benson put me on the slide and divide. It makes it so much easier. What you do for slide and divide is if there is a front leading coefficient like this 3, you are going to imagine yourself picking that 3 up and sliding it to the very end of the problem to where it gets multiplied by that -8. And then you're going to write the result. So this isn't the same problem as originally, but I'm kind of modifying it to make it easier to factor. You can go quadratic too if you want. That's fine too. Using quadratic formula will always get you the right answer. Can't wait to teach my kids slide and divide. Yes, bro. I taught like 3 years before I even learned what it was. So I was super glad when somebody put me on. But to who said it? I don't know how to say your name, bro. But you don't have to use quadratic formula. You can factor. It will look something like this. And I don't even know if I'm going to be able to factor this. But that's what I would get. That 3 is no longer in front, and it's not -8 because that got multiplied by the 3. Now we just got to think, what numbers multiply to -24 but add up to -2? If you're like me and you can't always think about it like off the top of your head, what I do is just start listing pairs of numbers that I know multiply to 24 or -24. And let's just see if I get a match. And I think I do right here. 4 and 6, I know it doesn't make negative 24. I got to make one of them negative. I'm remembering that I got to add up to -2. So I think I want my 6 to be negative. I want the bigger number to be negative. So here's how it works. I'm double parentheses x and x. And then I'm putting my two numbers, which were a positive 4. What time is it? 9 o'clock? Yeah, I'm about to be done at like 9:15. X plus 4 and then x minus 6. Remember, this is not the original problem that I'm factoring. When I slid that 3 over back up here, I modified the whole entire problem right there. So me factoring this is not the same thing as factoring the original problem. What I'm getting at is since I multiplied by 3 right here, I got to go back and undo that. So those two numbers that I thought of, I got to divide both of those, hence the name slide and divide. I got to divide both of those by the same number I slid. I'm not going to lie. That's what people forget to do. I myself have forgot to do it a couple times. But that is how slide and divide works. Whatever is left over is your factorization. So, also let me say this. That second factor, you can see that 6 over 3 just becomes 2. But if that doesn't happen, like when I say that, I'm talking about like reduced to like an integer, like 4 over 3, that doesn't reduce to a whole number. What you can do is write it like this. That 3 on bottom, I can slide that up in front of my x and go like this. That is how you factor. Now notice, we're not done. We're not done. I think this one, I'm pretty sure it asks us to solve. Yeah, we're solving. So we still got to get x by itself. But the good thing about factoring is, remember, two factors, their product is 0. So we got to take each case where both factors equal 0. Because remember, 0 times anything equals 0. So if I let 3x plus 4 equals 0, right? Whatever x is, that'll make that first parentheses turn into a 0. Or I can let x minus 2 equal 0. When I solve for x in either case, those are going to be the x values that make my whole equation equal 0. So those are going to be my my answers. What's today's stream about? This stream is about, I asked AI to come up with some problems to do for anybody who's like, well, not anybody, all y'all are about to be back in school. So I was like, let's do a little refresher and review some math that y'all probably would have forgot. So I'm just doing AI's problems. So I'm just literally solving for x at this point. So that's what 3x equals -4. And then I divide by 3. There's one solution. And then this one is just x equals 2. Hopefully you can see that one's pretty easy. No calc. I mean, not tonight, but tomorrow. What's tomorrow? Wednesday. I'm down to do some calc. We can start low key. Now that you say that, I kind of want to just start getting into the content now. Like I'm gonna just do like a teach of like the introductory parts of calculus and do some limits. I'm gonna probably do that. But all right, so that one was kind of complex just because we had to get common denominators first of all. Write it as fraction equals fraction. Cross multiply, distribute, turn it into a quadratic, factor the quadratic using slide and divide, and then solve each factor for x. So that one is a little bit of a process. I'm not gonna lie. What do I teach this year? This year they got me on geometry and calc. Geometry, I don't know how that's gonna go. I'm not gonna lie. We'll see. We'll just have to see. But all right. Let's try these word problems. These might be fun. Low key. I mean, 6 problems. Yeah, I might be able to finish these. All right. So, Anthony, what's good, bro? You missed it. I was just talking about you, and your moon method. I was putting people onto your moon method. That was like 20 minutes ago. A car travels 60 miles in 1.5 hours. What is its speed? I got that. So, for number one's word problem, the question is asking for speed. Yes, bro. Moon method is clutch. Every year since you taught me, I think it's been like 3 years since, I tell all my kids about not just the moon method, but my guy from San Antonio. I got to make sure to give credit where it's due, bro. But all right. Number one is asking for speed. Speed is just, it's in miles per hour. So if my distance is 60 miles and I cover that distance in a span of 1.5 hours, that result is my speed in miles per hour. Appreciate the like. Now, here's what I'm going to do. I know that 1.5 is like it is 3 over 2. Since I got 60 divided by a fraction, I'm going to keep change flip. I'm going to keep my 60. And instead of dividing by 3 over 2, I'm going to multiply by 2 over 3. And from here, I got two options. I can either go 60 times 2 and divide that by 3, or I can see the 60 divided by 3 and then times that by 2. Either way, you should get 40. But I lie. You shouldn't get 40. You should get 40 miles per hour. Just saying 40 is not enough. But that is my answer for number one. Speed equals distance divided by time. Drawing program, I'm using OneNote. I'm using Microsoft OneNote. I like it because it's free. It's Mac compatible and compatible. Mac and PC. And I can put my notes from the live like in my Discord. There's a section in there where you can download all the notes that I put. Do I ever teach physics? I don't, but I know a guy. I never have taught physics before. I'm math only. But okay. Next word problem. A rectangle has perimeter 24 and length. Well, they worded that so weirdly. A rectangle has perimeter 24 and length twice the width. Find its dimensions. I don't know about you, but I'm about to draw a picture. Because what? All right, we got a rectangle. It tells us that the perimeter is 24. Let me write that a little neater. Okay, so the perimeter is 24. I don't know the length or the width. That's the whole point of the problem. But I do know that the length of this rectangle is twice the width. Yeah, there is. One of my good friends teaches physics, and whenever I go in this class, it's a whole bunch of math, and people be struggling, bro. But all right, so it tells us that the length, I'll just call that L, is twice the width. All right, that L and that W, I'm going to put them on my drawing, and let's see what I got. So I'll call this length, since that's twice the width. Okay, figure not drawing the scale. But we got to figure out W and L. So we're solving for two variables. Notice that we essentially have two equations. I know it says perimeter equal 24, but if you know vocabulary, you know that the perimeter is just the sum of all the sides. So if I take W plus L plus W plus L, notice I added up two W's and I added up 2 L's. That is my perimeter, which they told us it was 24. Am I teaching middle schoolers? No. Yes and no. I'm not. Let me say that. I'm not teaching middle schoolers, but there are a lot of high schoolers who either forgot or just need a refresher from some like middle school topics. It is simple, but it's simple because you're good at math. It's not simple for everybody. But okay. I'm solving for 2 variables. I got 2 equations. In this situation, I would go substitution because if you notice, L is already by itself. So whenever I see an L, I can just put 2W, or whenever I see a 2W, I can put L. Either way, let's just try it and see what happens. So I'm going to go wherever I see a 2W, I'm going to rewrite my first equation, and I'm just going to put an L instead of 2W. So that's my 2W plus 2L equals 24. L plus 2L, that's 3L, equals 24. Divide by 3 on both sides. All right. Ooh, I got to follow. Appreciate you. Okay. 3, 6, 9, 12, 15, 18, 21, 24. My length is 8. And over here in this equation, now that I know L, instead of putting L, I can just put what it actually is, which was an 8. And that still equals 2W. Now I can easily solve for W. Y'all want to do calc tomorrow? I'm down. Okay, that is the algebraic way of doing it. But technically, I guess if you wanted to, if you knew that the length was twice the width, you can just half the length and get W. Either way, those are the dimensions. All right, number 3 looks like a good one. This is like a good problem solving one too. This low key might be my last one. I'm not gonna lie. Hour plus streams are not easy, bro. I don't know how people be doing 24 hours. But all right. It says a student scored 82, 90, and an 88 on 3 tests. What must they score on the 4th test to average a 90? That is a great question. They're trying to average a 90. They took 3 out of the 4 tests. Bro got an 82, a 90, and an 88. Just from the looks of it, it looks like he kind of got to go crazy on this last test. But we don't know what he has to score on the 4th test. And since I don't know that number, I'm just going to put an X. That X will represent whatever grade he needs to get on his 4th test. So when I average out the 4 scores, and remember, average just means I add them all up and divide by the number of things I add. That right there is the average. I want it to equal a 90. That is what he wants his average to be. So I'm just going to literally solve for X. All right. So what I'm going to do first is take this whole entire fraction and get rid of the 4. Actually, no, let me not use an X. I'll use a dot. Multiply by 4. Yes, I agree. So that gets rid of the fraction. So my next line is just going to be this right here. All right. If you don't know 90 times 4, just do 9 times 4 and then throw a 0 on there. 9 times 2 is 18. 9 times 4 got to be 36. So 90 times 4 got to be 360. Or you can think of it as 4 quadrants. And then from there, we just got to combine like terms and then solve for X. So I'm going to go 82 plus 90 plus 88, 260 plus X. We're almost done, y'all. Equals 360. And then you can kind of just think about it. What does X need to be? 260 plus what will give me 360? Bro has to do a perfect job and get 100 if he wants to average a 90. Brittany, Let's go. Can you put 1 underneath the 90 and cross multiply? You can. That is perfectly valid. I have no problems with anybody wanting to do that. I feel like at that point it's just preference. But yes, he needs to get 100. Okay. Next stream, I want to do. Yeah, I think I'm gonna do calc, bro. After doing a stream like this, I feel like I gotta follow it up with something a little harder. So I'll do calc. I don't know if I want to do like a teaching stream or just like a problem solving stream. I don't know. We'll figure it out. Maybe I'll ask my story or something. But in the meantime, W stream, I suppose. I'm going to get back on tomorrow. I'm about to go finish eating and lay down. I'm going to catch y'all. Appreciate the follows. Appreciate the likes. And I'm off of here. Yes, sir. Metro, I'm going to text you, bro.